Good day, guys. This is Marvel again here. We'll be doing this kind of functions. Is it a hyperbola or the, like, it's one of those things that it's important to know, but it's not. It's the name of the graph. It's I'm lazy on just checking on the book what's the name. I know about the graph, the function, but I don't know its name. It's more of that person you like, but you don't know their name, but you talk to them each and every single day. I had that experience last year. There was no. Let me not start to talk about stories. Okay, now let's start with this equation, right? Let's say you're given the function f at x that equals to a x minus p plus q, right? So what is actually happening? These negative p and q are actually the asymptotes, right? Is it the asymptotes? Let me just check. Write down the asymptote. Yeah, they are the asymptotes. So negative p and q are the asymptotes. So this is the x asymptotes and this is the y asymptotes. So whenever they ask you to write down the asymptotes, you simply say you're going to change the sign of this one. This negative p, it becomes p. Remember, it's the x asymptotes. And then this is q. It remains like that. It is actually the y asymptotes. Well, there's also the shape, of the of the graph, isn't it? There's actually the shape of the graph. So like, what do you see? This graph looks like it consists of a decreasing line, right? It is more of decreasing. If you draw a line here, this line is decreasing. It means that if the value of a is less than 0, the shape of the graph will look something like this. But this one is more of an increasing line, isn't it? So when the value of a is greater than 0, the line will this stuff. On each and every single function test you're gonna write, these ones will actually be there, and they are the easiest one for you to get marks for free. Now we're given this one, right? Let's just start. They say we're given f at x equals to negative. Let me just copy it. F at x that equals to a negative x minus 1, right? What are the questions? Now the questions say write down the domain of f, right? Write that the domain of f. Now I just forgot. Now remember, we've got the range and the domain, isn't it? We've got the range. What is the range? The range is the what? Set of y values where this graph exists. And then the domain, what's the domain? It's blurring, I'm sorry about that. The domain is the what? Set of x values where the graph actually exists, isn't it? So let's talk about something. I think this is important for me to talk about it. Let me just use a dummy, a dummy, what we call. Okay, let's say we're having this graph, right? It is having something like this, right? And then it is also having something like this. All right, so our asymptotes here are actually at 0. So our asymptotes here are actually at 0 and 0, right? So like, what do we know? We realize that this graph is coming from negative infinity and it goes up to positive infinity. It continues to positive infinity while it is coming from negative infinity, isn't it? But we realize that the graph is everywhere. The graph is everywhere except at 0, right? Except it is not touching the 0 part. It is also not touching the 0 part. So it means that when we want to calculate the domain, the range, okay, let's just talk about the domain. That is the set of x values, right? The set of x values. We say that XER. XER means that it exists everywhere. Okay, perhaps let's just say this. It exists everywhere, but not at x equals to 0, right? The graph is everywhere, the graph is absolutely everywhere in terms of x, right? Even here in terms of x, it is everywhere, but excluding here at 0. Same thing with the range. You say that it is YER. It is everywhere, but not at y equals to 0, isn't it? The graph is coming back from negative infinity and it continues to positive infinity, but it is not touching the 0 line, isn't it? So that's your domain and your range. Now let's actually come here. We are having this equation. We can see this is the same as plus 0. They say write down the domain. What is the domain? The domain is the set of x values, right? So this is what you do each and every single time. You say that the domain is XER. It exists everywhere, but not at x equals to what? At this point is going to be 1, because it's going to change side. It's -1. You change it the side to be 1. That is your domain. That's how you write your domain. Let's say we are actually given this. Let's say we are given f at x equals to -3/4 divided by x plus 3/19 plus 100. When they tell you to write your domain, right? When they tell you to write your domain, you say XER, but x not equals to what? So this is 3/19. You're gonna change its signs to -3/19. Do you understand? That is your domain. So at this point, your domain is XER, but x not equals to 1. You're just gonna change the sign of that. Okay, let's go. Now they say write down the asymptotes. What did we talk about? We did talk about the asymptotes. We said the asymptotes, you just change the value of whatever number is in here. It becomes positive p. It is the x asymptotes, and the y asymptote is just this q over here, right? So this is what we do. We say that the asymptotes of this one, we are given this one, is going to change into what? +1, and the y asymptote is what? Is 0, because we're given nothing there, isn't it? Now they say sketch the graph of f. So now they want us to sketch the graph of f. How do we sketch the graph of f? We come here and sketch the graph, right? Now let's draw these lines of asymptotes. So the first line of asymptotes is actually at the +1, isn't it? I don't know why it's blurring. So the first line of asymptotes is actually at a +1. So you come here at a +1, you draw this line of asymptote, all right? So it is actually at a +1, and then another line of asymptote, it says 0 for the y part, right? So you're going to come here and draw this asymptote, right? So they want us to draw the sketch, right? They want us to draw the sketch of this graph. So what do? First and foremost, determine the values of determine the value of y, the y-intercept. How do you determine the y-intercept? If you are given this, you are given f at x equals -1/x minus 1. If you determine the y-intercept, it means that x equals to what? X equals to 0, and then -1 divided by 1, it will be 1. So it means that the y-intercept will be here at 1. So because we know we don't have the x-intercept, right? How do we know we don't have the x-intercept? Because the y asymptote is actually touching the x-intercept and the x-axis, and we know that the graph do not touch the x-axis, right? So how do we actually do this? So this is how we're gonna do it. We're gonna draw it like this, because this is a -a. You see, this is a -a. What did we talk? We know that when the shape we know that when it is having a -a, this is the shape of our graph, isn't it? So we have to draw something like that, but it will pass at x is equals to 1, and then it goes like that, and then it's going to be something like that. So that's how you actually draw it. Okay, let's move into the second question. Okay, for the second question, we are given What are we given? We are given g at x, right? We are given g at x that equals to 6 x plus 2 minus 1, right? So the first question say, write down the equation of asymptotes, right? What are the equation of asymptotes? This will become negative 2 and negative 1. You now understand that, right? And now they say calculate the x-intercept of g and the y. Oh, sorry. Now they say calculate the x-intercept of g and the y-intercept of g. So how do we calculate the y-intercept of g? We know that for the y-intercept, x has to equals to 0, right? So we're going to have 6 divided by 0 plus 2 minus 1. This is going to be 3 minus 1. That actually equals to 2. So the y-intercept is 2. How do we calculate the x-intercept? When we calculate the x-intercept, we know that the g has to equals to 0, right? We're going to have 0 that equals to 6 x plus 2 minus 1. So we're going to take this to the other side. We're going to have 1 equals to 6 x plus 2. We cross multiply. We're going to have x plus 2 that equals to 6. It means that is 6 x is going to equals to 4. So we have y that equals to 2 and x that equals to 4. And now what is the next question? The next question say draw the graph of g, right? We need to draw the graph of g. How do we draw it? We come here, and the first thing that we do is to sketch the x and y asymptotes. The x asymptote is actually at negative 2, isn't it? So I'm going to come here and sketch something at negative 2, just this dotted line, and I write this is negative 2, and the next one is actually at negative 1, isn't it? And then I'm going to come here and sketch something, and this is actually at a negative 1. But what are the x and y intercept that I have? I have the x intercept at 4, and I also have got the y intercept at what? At 2. So this is how my graph is going to be. It is 4 and 2. So it means that the other one is actually going to be like this. Okay, that wasn't hard. Okay, determine the equation of the line of symmetry that has a negative gradient. This question is phoned to the exam. Listen to this. It is very easy. They say determine the equation of the line of symmetry that has a negative gradient. Let me teach you something. We've got two line of symmetries on this graph. The first line of symmetry that we have is this one. They always pass at this point, right? And then the second one we have is this one. So yes, here are those lines. This one has a positive gradient, or as you can see, it is what? Increasing, right? It is increasing. This one has a negative gradient, or it is what? Or it is decreasing. So when they say determine the equation of the line of symmetry that has a negative gradient, it means they want you to determine the decreasing one, right? It has a negative gradient each and every single time. This is something you can know. The gradient of the decreasing line is m equals to negative 1, and the gradient of the increasing line, it is m equals to 1. Are we understood? Do we understand this? The gradient of the decreasing line, it is always m equals to negative 1, and the gradient of the increasing line, it is always m is 1. So they want us to determine the line of determine the equation of the line of symmetry that has a negative gradient. So what do? We know we have this point, right? Isn't it? What is the coordinate of this point? The coordinates of this point turns out to be these. They are the equation of asymptotes. They are the point of where these asymptotes are actually crossing is negative 2 and negative 1. So we're going to say y minus 1 equals to m x minus x1. What is y? Y is going to be negative 1, is going to correspond to be positive 1. Y is negative 1 because it is decreasing. X, it will be plus 2. So y is going to be negative x minus 2 minus 1. That equals to negative x minus 3. So that is your equation. right? So here the last question say, determine the values of x for which this is greater than this. So just solve for x here. You are going to cross multiply and do whatever it is that needs to be done. Just cross multiply. I'm not wasting my time on that. I'm already tired. I'm not wasting my time on that. Okay, let's look at another question. I thought I had two questions, guys. I cannot find the other one. Oh, here it is. Let's look at this one and how it's done, right? Here it is. What's actually happening here? We are actually having this. They say, consider f at x that equals to 6x minus 2 plus 3, right? So let me just write this. We are given that we need to consider f at x that equals to 6x minus 2 plus 3. And the first question says, write down the equation of asymptotes, right? Write down the equation of the asymptotes. What are the equation of the asymptotes? We know that x equals to what? X equals to 2, right? We know that x is going to equals to 2 and y is going to equals to what? To 3. Now you know how this is actually done. The second question say, write down the domain of f, right? Write down the domain of f. What is the domain? The domain is actually the set of x values where the graph actually exists. So I told you will write xer, but not at x equals to 2, right? That's how you do it all the time, right? Now we come here, draw the sketch of the graph. How do we draw the sketch of the graph? We're going to come here. The first thing that we do, we are going to sketch the x and y asymptotes. The first one is x at x equals to 2, right? We're going here to draw something at x equals to 2, and then the other one is at y equals to 3. This one is going to be at y when it actually equals to what? When x equals to 3. So this is 2, and this is actually what? And this is actually 3. Okay, so what's something that we need to know? Now we need to identify the, what is this? We need to identify the values of y, right? We need to find the y value or the y-intercept. And how do we find the y-intercept? We know that the y-intercept is going to be when x is equals to 0, right? So this is going to be negative 3 plus 3. So the y-intercept is actually at 0. So we know that the first y-intercept is going to be here at 0, right? And then what about the x-intercept? So the x-intercept is going to be when the x-intercept is when f at x equals to 0. So we're going to have 0 equals to 6 x minus 2 plus 3. So we take the 3 to the other side. We're going to have negative 3 equals to 6 x minus 2. We cross multiply. We're going to have negative 3x plus negative 3x plus 6. That actually equals to 6. Yeah, I think this is correct. Negative 3x plus 6 equals to 6. So negative 3x equals to 0, and then x is going to be 0, right? This one is it is not making sure, but there's nothing I'm gonna do. It means that the x and y intercept are actually at what? They are actually at 0. All right, the x and y intercept are actually at 0. So it means that my graph will actually look something like this, because they actually move at 0 and then they actually come here, right? So that's how you actually draw the sketch. Okay, write down the equation of symmetry that has a positive gradient. So we need to write out the what? Write down the equation of symmetry that is a positive gradient. As I've already told you, we are having this symmetry that is this one and then this one. So this time they want us to calculate this one that has what? A positive gradient. And we know that m is always equals to 1 because it is actually increasing. What are its coordinates? The coordinates of it is x equals to 2 and y equals to 3. So I'm just going to say x equals to 2 and y equals to 3. So I'm going to say y minus y1 equals to m x minus x1. So y minus y is going to be 3, m is 1, x minus 2, y is going to be x minus 2 plus 3, so y is going to be x plus 1. Ladies and gentlemen, that will be the end of today's lecture. There's nothing interesting about this, by the way. It's just like plain stuff that all of you already know. You just need to practice them. And now I have a work. Just write this one as a homework. Otherwise, I'll see you at the next lecture. Enjoy the rest of your day.